The first variant that we are going to see will be based on the same black box, namely the black box consisting of a spring and just applying one input, this W, and producing one output, L. So the same black box that we have used to fit our linear regression may be used to fit some other type of linear model as well. The linear model that we are going to discuss now is the type that we have already started talking about in class, namely quadratic regression. So in this case, I have the same Li and the same Wi. I have repeated the experiment with possibly different weights, and for each case I have recorded the weight applied Wi, no randomness there, perfectly known, and I have got different types of length or different measurements of length, and now I am relating them with a different equation, Li equal to beta 1 plus beta 2 Wi plus beta 3 Wi square plus the inevitable random error which is always present. Now this is a quadratic regression, and as I have discussed in class, though it is quadratic in W, in weight, it is still linear in the coefficients. For us, the unknown quantities are the beta. So if I want to write it as a linear model, I can do it like this, where the design matrix will be this quantity. This matrix 1 1 1, then W1 to Wn, and then W1 square to W1 square, W2 square, Wn square. So all these things are still just as the same format, y equal to x beta plus epsilon. Now the question is, how do I represent this inside the computer? And there this lm command will change slightly. So lm, L, that is this output, the response, tilde stands for that approximate equality, W, that is for the linear term, and then W square, but I have already told you that you need to put it inside a wrapper. That wrapper is the capital I function. It's like a function, it's more like a notation. So it's that wrapper which says W square will be preserved. If you do not do that, then W square, strangely enough, will be treated just as ordinary W. So in our session that's going to follow, we are going to see what happens if I write just W square and what happens if I write IW square. So here we will be again starting with our familiar data set, the spring data set, which I am showing in this part of the screen, our familiar data set, and I am going to load it. So I have written a little one-line command. I have done it in a script file instead of typing it directly here at the prompt, because if there is a mistake, I want to change it in my script file. So I will just execute that line, and I have loaded it. Now I want to explore whether the file is okay, dimension dt, that looks fine, this is my data, yes, it's fine. So when I explore something, I put all those commands directly at the command prompt, but any line that I want to preserve, I will put it in the script file. Okay, so now I want to create my linear model. So I will write fit equal to lm, what is it called, length tilde, I will write weight plus, I said I will use weight squared, and I have to specify the data set name, that is DD. So I will execute that command. I do not get an error message, so I will explore it. So I will type things here at the command prompt fit, and the coefficients are, as one would expect, there's an intercept, then there is this coefficient for weight, and there is this quadratic coefficient. Notice that I have written that R has written E minus 16. This stands for 10 to the power minus 16. So there are so many zeros before it. So if it is 10 to the power minus 16, there are 15 zeros, then 4, 6, 7, 9. So it is as good as 0. And that's what we expected, because if I looked at the plot, and I should always have made the plot to start with, if I look at the plot, that is length versus weight from this data, F7, I am actually getting just a straight line fit. So the quadratic part is 0. That is as expected. Well, now we can find out what is the fitted values, but first what I will do is, now that I understand, I really do not need to keep this quadratic thing. I can go back to our original thing. So I will just do it, copy paste, give it a name, call it fitlin for linear fit, and get rid of this. And so I get rid of that, and let's take a look at the coefficients of fitlin. Here I see 3.283, and what was the thing that I saw earlier? 3.283. Well, same. And here I have 2.010, and here also I have 2.010. So effectively this is not playing any role whatsoever. So what I will do is that possibly I will keep this fitlin and then remove this fit. So this is how you typically carry out analysis. You have a model in mind, and then you can either add more terms or take away terms. In this case I removed the terms. Now let's take a look at what happens if you do not want to put that I. If you by mistake forget to put that I wrapper. Let's see what happens. So I will give it a name. I will call it fit wrong. Fit wrong. And I will not put the I. So let's try to execute it. There is no error message. So I will say fit wrong. And it says simply reported intercept and weight. So it has not. Sorry. I have a very little mistake. I wanted to say weight squared. So I will execute that. Now I will try to see what is fit wrong. But it is still intercept and weight. In spite of the fact that I wrote weight square, but it is still taking it as weight. That is because when you are inside a formula object, that means something involving a tilde, then after the tilde, these plus or power or multiplication, they do not mean their usual things. So it is something like a Boolean operation, like a Boolean or and, just as weight or weight, that will be same as weight. Weight and weight, that will be same as weight. I can even try this if you want. So I will just explore this further. Oops. So I will call it fit wrong 2, and weight times weight. You will see still weight times weight will be weight itself, that plus weight will again be weight itself, somewhat like a Boolean operation. Now why it does it in this way is something that we'll understand later. So let's try this one out, and you will find that still you will get the same old story. Let's try the model matrices. What I got, model matrix. I will try it first for fit, where I remember to put the I. Now I really have intercept column, then the weight columns and their squares. But if I try for any of the other things, whether I try for fitlin or I try for fit wrong or wrong 2, I will always get only one column. So it is just a lesson that you should remember to put it inside a wrapper whenever you are using any such function. Okay, that's it.